TPA3255 Part 2 hands-on real board. I took one real board, what in my opinion is interesting, and it's not reviewed in a YouTube and in Audio Science Review. It's a 4-channel board, and it is perfect board for exclusively good home theater. As well as you can build some kind of three-way speakers, not a premium one, but for a tests, those are very good. Here is set, one power supply, and this China developed board. This board has a longer life cycle than many other boards where you see number of versions, they appears and disappears later on. Those has balanced inputs. If you want to have a passive cooled multi-channel home cinema system with 24 channels, for example, then this vertical placement is the best. If you inspect under the microscope, you can see that a decent quality. I would say very good quality. It's built in a good factory with a good manufacturing process, and no complaints, even the smallest one, for quality how this board has been built. It's hard to say what is the purpose of this board. Is it DIY board, or there are some places where this board is used as in professional manufacturing? Who knows? But overall, I'm really happy how this board looks like. Under the microscope, let's take a closer look what kind of critical components has been used in this board. From theory, from part 1, we already knew that there are a number of critical components which should be inspected when you take a final decision, could we use this board or not. You can see that this board is using TL07 series operation amplifier, and let's check the characteristics of this chipset. If we look at datasheet, a lot of similarities with NE553, but this board has better sleeve rate, 20 volts per microsecond. It has higher noise, about 3 times. Very low consumption. They also mentioned low total harmonic distortions, 0.003, but below in a datasheet for small signal it is 10 in more. What is the drawbacks of this chip, of this op-amp? Practically there are no drawbacks except one: it can't work on a 600 ohm load. That minimum I think is above 2 kilo ohms and recommended 10 kilo ohms. But for if you properly build your circuits, then it's perfect. Good chosen op-amp. Hard to say, is it original or it's some third party? I don't know. You can't tell it from that particular chip markings. Commodity linear regulator, they also use the same architecture as in reference design. Down converter and then stabilized by 12 volt linear stabilizer. In high power package, no comments here, commodity solution, but it's built by the book. A voltage down converter, let's check datasheet. What is the maximum voltage what this chipset can handle. Here is our chipset, XL7005. On the first line we can see it's 100 volts rated, so it exactly fits in our design. What manufacturers are telling about it: maximum output 0.5 amps, no more than 5 watts. It may happen that one of the reasons why designers use those low consumption chipsets are power constraints. Who knows? Anyway, it's a perfect chipset. It's original Chinese manufactured chipset. Is it good? I guess yes. If you look the world market of chipsets, then China is taking niche of medium and low integration chip top manufacturer and provider. This is exactly fits in that niche, and I would use it in my designs. I check the prices, and you can save about 40% of your design when you're using this chipset, comparing to Texas Instruments analog. Those probably are almost the same. And now brief look at the power supply. I choose industrial power supply. It's decently built. I have a couple of complaints, and one that there is no surge protection on board. You need a separate mechanical installation of surge protection. Also, it has PFC, and you may think that this capacitor is too low for a 400 watts power supply, but in PFC circuits you store energy in inductivity and in capacitor. It's flyback design, so it's noisy. You need a large filter and output, and it's not very good power supply for audio amplifier. Definitely you need additional storage capacitor, because there are very small storage capacitors on a board. You have possibilities to regulate the voltage in 10% from the core voltage. There are 4 contacts outputs and 2 of them are parallel. Here is my capacitor. It's very good KMN capacitor with 10,000 microfarads capacity. It's 10 years old. It was in our warehouse, left over from some project, but probably this is one of the best capacitors you can get for your project, and mainly due to the very low serial resistance, 0.01. It's absolutely perfect at 1 kilohertz. It's very, very good. Now I'm setting board in a test mode, and I'm going to use not a balanced but single-ended input or unbalanced input. With the jumpers you can set them in a proper way. I have good signal generator, Tektronix signal generator. Arbiter signals are developed in a good quality. Here is my load equivalent. No load, load, 8 ohms, 4 ohms for one channel, 8 ohms, 4 ohms for the second channel. And you also need for this power supply somehow high frequency filter. This ferrite works as a high frequency filter. For tests I'm not using my best capacitor, but it's good. We use a Fluke oscilloscope, and it's set to measure amplitude and frequency. And now you can see that output signal is perfectly clean and nice. As I mentioned, that power supply is very noisy, and this noise is coming on input signal. Meander is used to evaluate frequency characteristics. You can easily see them if there is a slope drop, as you see, the 8 ohms, 4 ohms, 8 ohms, 4 ohms. Those frequency characteristics you easily can evaluate. For example, if your frequencies has a high frequency additional gain, there will be overshoots on meander. Otherwise, it's almost perfect. There I put a sweep from 20 Hz to 20 kHz to evaluate full frequency range. How does it look? I will add also input signal that we compare inputs and outputs. So without load currently it's absolutely flat in both cases. But now let's switch 8 ohm load, and with 8 ohm load there's slight drip, it's 1 decibel, and with the 4 ohms there's more drop, it's 2.4 decibels drop. This is how it looks in reality. Those are neglectable drawbacks, but you can clearly see that board is optimized for 8 ohms, and I think this board is for home cinema, and majority of home cinema loudspeakers are 8 ohm loudspeakers to make those receivers more efficient. Let's measure real drops and check is it as I thought. So we set output signal at 10 volts for 1 kilohertz, and now it is 4 ohms 7.6 and 8 ohms 8.9, 4 ohms 7.6 and 8 ohms 8.8. Okay, so anyway, there is a slight drop on a high frequency on 20 kilohertz. Let's do quick calculations, how much it is in decibels. So 0.88, calculate, it's minus 1.1 dB on 8 ohm load. And let's calculate for a 4 ohm load, 0.76, calculate, it's minus 2.3, 2.4. Yeah. Actually, for 20 kilohertz, it's not a bad result. Why engineers did it? That's a good question. I have no clue. But it seems it is optimized for 8 ohm load, 0.88, 1 dB is neglectable, and it's perfectly fine for 8 ohm load, and also for no load at all. Let's look at realistic speaker impedance. You can see there is plenty of loudspeakers with impedance, and you can see, for example, this impedance versus frequency here at 20 kilohertz we have values more than 10. Practically this board will be flat. If you take a single loudspeaker, then the impedance is going up, and it depends on different speakers. If you make active system, you are directly connected to speaker, and there could be different values. Actually, those values varies from about 5 ohms to 20 ohms, what I saw. Let's take one example of a loudspeaker, and let's take Tommy tweeters. There's plenty of tweeters from different manufacturers. Let's take a 4 ohm SB acoustics and look at the data sheet, and you can see that at 20 kilohertz we're still at a 4 ohms. So for example, this tweeter has this 2 dB drop. When we look at the frequency characteristics, they are peaking for couple of decibels, somewhere around 15, and at 20 kilohertz they are rather flat. So we will have some slight drop. And as I mentioned, on 20 kilohertz it is almost impossible to hear some decibel differences. Also, you should count that your room impact is about 10 decibels. So normally if you are listening such kind of amplifier with that drop on a 20 kilohertz, they should sound pretty linear. Yeah, they should sound neutral. But strictly talking with the measurements, yeah, we can complain that there is a voltage drop. That particular board is optimized for 8 ohms. Let's take another example from 8 ohm Tommy tweeter data and audio. Kind of okay. Let's look at the data sheet, and what we see that impedance is 10 ohms. If you build some active speaker system and you're looking for a perfection with this board, for example, this tweeter will be totally neutral, totally perfect from from amplifier side. But if you look at the tweeter itself, it is dropping at 20 kilohertz is dropping for at least 3 decibels. At least 3 decibels. You can see that particular loudspeaker already is not perfect at 20 kilohertz. So everyone who really complains about details on 20 kilohertz, you should count how important it is. There is no music. There's no music above 16 kilohertz, only harmonics. And our capabilities to hear it, your kids probably hear it. But if you are at the age of 35, 40, you will not hear it. You don't hear 20 kilohertz. Do a test with good headphones, and there is generators in online signal generators, and try to listen. Do you really hear 20 kilohertz? And then start to complain about it. Those lower end is far more important. Far more important. How you can reproduce bass? Is it? Do you have a good power supply? All those things are far more important. Let's check critical components. I'm checking inductivity. It's 9.3 microhenries. And let's check are they the same or are close in parameters. And you can see that pretty good, decently built inductivities. Relatively small capacitors. Let's check capacitor capacity. Very precise capacitors, 1 microfarad. I would say that this board is surprisingly good. And now we should check also what is on board electrolytic capacitor total capacity. And you can see it's 1.6 millifarads or 1600 microfarads. So it's time to test how it sounds. We did all tests and checked all components. This is a decently built board. I would say it's surprisingly good built board, and I will find out some designs where I can implement it. Definitely after the measurements, I took the decision to use this board. But we should understand that it seems more DIY board than professional board. I will test it on 4 ohm load speakers. I have 4 ohm speakers, passive speakers. So I should use what I have. We start with the drums. Drums are important. Of course, my mic is far above and away from the speakers. It sounds like in a box. But anyway, so this is end of part 2, where we had hands-on on a board. We tested it, and my evaluation of this board is it's a very good board. It's decently built. It's 8 ohm optimized. And in this case, it's really 8 ohm optimized. Even with no load and with 8 ohm load, they perform practically flat frequency characteristics. I don't have a good power supply, but even with slight modifications and with additional storage capacitor, I managed to get very good sound. It's rich, it's clean, it's clear. Very low distortion of this board. It's built by the book. Practically everything what we checked are taken from reference design. It's small in size, and my guess is that a niche for this board is home cinema, especially when the modern home cinemas coming out now with 7, 8, 16, 24 channels. This is the future of home cinema. You have loudspeakers on the ceilings, you have loudspeakers on the back, and you have loudspeakers back on the ceilings, and you have loudspeakers in the middle. The modern home cinemas are moving to multi-channel environment, and this board could be used for that. If I somehow look further of home cinema development, I think splitting power part from processing part is a right way to go. Even today we have Sony or Panasonic or Denon designed receivers with multi-channel outputs. A logical step would be that you split payment into parts. One part for the signal processing, because what continuously developing, and the second part for amplifier. If you split them, then you have option to upgrade only part of that. Because I would say that if you use this board for your home cinema, you don't need upgrade. Only if you need a lot of power. But you know, for a mid-range, 100 watts for mid-range is crazy loud. Only thing where you need a real power is for subwoofer, and then you can only change some subwoofer amplifier. You can use even professional grade amplifiers to drive a subwoofer. It's a cost-effective solution. So high ratings for this board, and I see several applications. Home cinema, and also it could be for a lower grade three-way speaker systems. But anyways, those speaker systems will sound excellent due to the higher efficiency, and you should drive only small part of the bandwidth with each amplifier. So very good design, and I hope these Chinese developers will keep it in the market for a longer term.